Okay, great. So good morning, good afternoon, or good night to everyone. Thanks so much for taking the time to join us today. It's good to see some of you again, and then it'll be great to meet some of you for the first time. My name's Kit McManus, and the project that we're going to be talking about today is called the Science Core Heuristics for Open Science Outcomes and Learning, or the School project. And I'm really happy that everyone is able to make time to be here today. So before we get started, I wanted to just put some emphasis on the code of conduct. TOPS, we're striving to create an inclusive culture that encourages empathy and humility and people to participate actively in an authentic way. In doing so, we should exercise consideration for others, and we assume that everyone will listen carefully and be actively involved. They'll ask questions, and we'll try to understand each other to the best of our ability. I want to encourage everyone to listen to each other as much as they speak. And, we want to treat everyone this goes without saying, we want to treat everyone's identities and cultures with utmost respect. So it should be a good meeting. Let's try to adhere to this code of conduct. I do want to let everyone know that this meeting is being recorded, and it will be posted on our project YouTube and on our project Zenodo. So if you have any reservations about that, please reach out in the chat or reach out to us separately. But just want to give a heads up that the meeting is being recorded. So with that, I think we should just go around the room and introduce ourselves. As I said, my name is Kit McManus. I'm the primary investigator for the school project. I'm a GIS developer at a research center called Season at Columbia University, where I spend a lot of time working on creating socioeconomic data sets for a project that we've run for NASA for more than 25 years now, the NASA Socioeconomic Data and Applications Center. I also am an adjunct lecturer of GIS at Columbia College, where I teach spatial analysis to sustainable development undergraduate students. So with that, I'll pass it over to Linda. If we just say who we are and where we're from, and for our open science team, also what made you interested in this project. But first, Linda, go ahead.
Sure, thanks, Kit. So my name is Linda Pistolacy. I'm also a GIS specialist at Season. I'm Kit's colleague. My role in this project is more of a bit of a project management, task management. So helping to kind of keep things on track with the various parts that we're developing. I also teach an intro to GIS class at Columbia College. And I'm also heavily involved in the CDAC project at Season, working on our flagship data set, the gridded population of the world.
Thanks, Linda. Camilla?
Hi, my name is Camilla Green. I work with Kit and Linda at Season, and I've emailed many of you about these meetings. Just really excited to get started with the open science team.
Thanks, Camilla. Greg?
Hi, everybody. My name is Greg Yetman. I'm Associate Director for Geospatial Applications at Season at Columbia. And on this project, I'm providing some technical expertise and I guess advisory input.
Thanks, Greg. Josie?
Hi, I also work at Season as a research assistant, and I am part of the development team for this project, working more on the narrative side of things. Nice to meet you all.
Thanks, Josie. Juan?
Hi, everybody. How are you? My name is Juan Martinez. I'm a senior research assistant at Season. And for this project, I do a little bit of coding, as well as some of the GitHub work. Nice to meet you all.
Thanks, Juan. Hashim?
Hi everybody, my name is Hashim Engin. I'm a GIS specialist at Season. I am contributing developing modules in this project. Thank you.
Thank you, Hashim. So that's all of us on the Season team. Now let's hear from our open science participants. Albert, are you willing to start us off?
Yes, well, my name is Albert Sanchez. I'm an associate researcher at the National Institute for Space Research in Brazil, INPE, where I work basically with Earth system science. I specialize in land cover, land use changes, particularly the Amazon forest. Basically, I'm a geoinformatician. Basically, I do data analysis using R, sometimes Python, of satellite imagery in order to look for deforestation and forest degradation. Thank you.
Thank you, Albert. It's nice to meet you. Jinyi? You're muted.
Can you hear me?
Yes.
Hi, I'm Jingyi, and I'm a PhD student from the University of Iowa, and I major in geographic information science. And for now, I'm doing a project to investigate the social vulnerability to the drinking water quality in the Iowa. And that's why I'm interested in this water module. And also I'm interested in the curriculum design and for the AI for sustainability. And so I found it very excited for me to join this project to see how to make the science engage to the public.
Thank you, Jinyi. It's good to see you again.
Yes, very good to see you.
Thanks. Lara?
Hi, everyone. I am Lara Pistolesi. I'm Linda's sister, and I'm in the process of pivoting my career into sustainability. I'm currently doing a master's in environmental management and sustainability. So I'm just trying to build my network and build my resume. So my sister offered for me to jump on this, so here I am.
Thank you, Lara. We're happy to have you.
Thanks.
Hazam?
Good morning, everyone. Can you hear me?
Yes.
Okay. Good morning, everyone. My name is Hazem Mahmoud. My background is geophysics. I am working at the Atmospheric Science Data Center based here at Langley Research Center, Hampton, Virginia. So basically, it's a data center like the CDAC, socioeconomic. And this year is the year of open science. We are in the end of the year, and this is very exciting, like to keep the effort going and learning more ideas and innovative ways to move toward open science. Thank you.
Thank you, Hazem. It's good to see you again. I think we met briefly at the Open Science Tim meeting a couple of months ago.
Yes, nice to meet you.
Robin?
Hello, I'm with the National Snow and Ice Data Center, which is a DAC for University of Colorado Boulder. And I'm a software developer there. And yeah, we're focusing obviously also on the open science, year of open science. So this was sent to me by a colleague.
Great. Yeah, I've interacted with Kate and Amanda quite a bit. So love NSIDC. Nice to meet you.
Nice to meet you too.
Juan?
Hi everyone, I'm Xuan. I'm from Texas State University. Currently, I'm a data curation specialist in the Research Data Service Department. And this year, our institution formed Open Scholarship team. So I want to know more about open science and how CI can help with. I also have a background with the PhD in educational psychology. So I'm doing a lot of research in social science field. Thank you.
Oh, great. Thank you. It's great to have you.
Thank you.
And finally, Anis.
Hello, can you hear me and see me fine?
Yes.
Okay. Hello, everyone. My name is Anise Williams. I am currently the Environmental Management Systems Coordinator for the City of West Palm Beach. Just a little bit background about myself. I have my bachelor's in marine environmental science. I also have my master's in marine biology. Bachelor's was at Hampton University in Hampton, Virginia. And my master's was at University of Miami at Erasmus. What I currently do quickly is I do a lot of environmental compliance. So we have our own water treatment plant and wastewater treatment plant. So that was one of the reasons why I was interested in joining. And also I deal with the public, working with the city, and do a lot of environmental awareness with our employees. As a public utilities employee, you're supposed to do 3 environmental awareness classes. We own our own nature preserves. So that's like canoeing, they can go hiking on the job. That's just a way for them to get outside, but also learn more about our environment and how we have impacts on it. So glad to be here. Thank you.
Thanks so much. You were glad to have you. And, I just want to say it's really exciting just to hear all of these different perspectives. And, we really pride ourselves on it being inclusive to all of these different viewpoints that each of us can bring to the table. So thank you again so much for agreeing to take part in this. So with that, I'm just going to give an overview of the project and kind of where we're at now, and then we'll have time to have a discussion at the end. But at any time while I'm presenting, if you have a question, feel free just to jump in and ask it. So first, just taking a step back, this program, it's funded under what's called a TOPST grant. So what is NASA TOPS? NASA TOPS is the Transform to Open Science mission. As you mentioned, we are in the year of open science, and TOPS is one of the forerunners, I think, in the federal government of pushing forward this vision where new scientific discoveries are enabled by being more inclusive. This idea of accelerating scientific discovery. TOPS mission is to inspire and empower scientists, research, and communities to embrace open science as a catalyst for positive change and leading to a more equitable and impactful scientific ecosystem. So it's the year of open science. It's year 1 of a 5-year commitment that NASA hopes will help us to accelerate those discoveries, to broaden participation, and to increase understanding and adoption of open science principles and techniques. So this begs the question, or getting a little ahead of myself, sorry about that. I just want to emphasize one more time that the idea is that by being more inclusive, we're going to get more people, more hands, eyes, and brains with different perspectives, looking at some of the toughest questions that we're facing, whether that be climate change, whether it be risks to water resources or agriculture. The thought is, and I think this is proven out in other, crowdsourcing type initiatives that are out there and citizen science initiatives, is that when we get more eyes on the problem, we'll achieve more and we'll achieve it faster. So, open science really is about bringing more people into the fold, providing more opportunities, and solving some of the world's most pressing problems. One of the major early deliverables that TOPS has produced is this Open Science, or OS 101 curriculum. This was a project that was undertaken with the American Geophysical Union, or the AGU, and it's produced 5 modules on the ethos of open science, open tools and resources, open data, open software, and open results. And these are about to go live in production Their target date is December 9th. So pretty much any day now, these modules will be online for us to utilize. What it's going to do is it's going to help us to get recognition for the fact that we have become experts in open science, which should help people on, on their resumes, and also for those of us who are pursuing grant funding, having this knowledge and these badges are going to help us to have a better chance as we put in proposals. So that's a TOPST Open Core. Our project is the next iteration of that, and it's called the Science Core Initiative. In Science Core, it's also embodying these open science principles, but it's focused on bringing in domain-specific knowledge. Whereas Open Core was general, and it's about just the open science in general. Science Core focuses on specific domains like water resources, agriculture, climate, disasters. So it was a Rose's opportunity in the last iteration, and we were lucky enough to be one of the 10 awardees that are listed here on the page. So these awardees, there's 4 of them, including ourselves, who are focused on curriculum development, and then there's 6 others that are focused on delivering open science content to virtual and in-person cohorts. So our project, again, I've described this nesting of, there's the TOPST project, which has Open Core and then Science Core, and underneath Science Core, that's where we sit. So we're the school project. And so what is the school project? First, I want to mention that many folks especially from our Columbia University team are on the call today, but there are a few people who couldn't make it that I want to acknowledge. Sri Vinay, who's our director of IT at Season and a co-I on the project. Christina Diodatis, who is a research assistant, and Naveen Ade, who's also a research assistant, are part of our Columbia team. They couldn't make it today. We also are working closely with a couple of other organizations, namely a group called iSciences, which is the expert software design and GIS intelligence group. And I want to acknowledge Tom Paris, the president of iSciences, Josh Brinks, and Dan Bastian, who are all major developers for us. We're also working with the CUNY Institute for Demographic Research, or CIDR, which is at the City University of New York Baruch College in downtown Manhattan. Working closely with Deborah Balk, who is a demographer and a prolific researcher, and some research assistants there, Elaine Famutimi and Iris Cano. So what are we doing? The objective of our project is to develop Science Core curriculum that incorporates NASA Earth science applications, data, and use cases, and explicitly shows the data science life cycle. So this will be achieved through the production of 7 2.5-hour-long learning modules that are designed both for asynchronous delivery online, but also in a way that they're adaptable for in-person instruction. There are 7 themes we're looking at. I've mentioned a couple of them already. Today, obviously, we're focused on water resources, but we'll also be looking at health and air quality, environmental justice, disasters, wildfires, agriculture, and climate. And, as we mentioned, several of us, we're, our expertise is in socioeconomic data. So across these 7 earth science themes, population and infrastructure is something that we'll be weaving in every time. So in terms of this project timeline, you know, we have these 7 modules. Our team was also committed to training ourselves in the OS 101 Open Core. Here we are in December 2023. So in the water resources module, we really have about two more months before this module is set to be released. You know, concurrently, we'll kick off in January our environmental justice and health and air quality modules. And then we'll continue every 6 months to take on 2 modules. So by July of 2024, we'll be working on disasters and wildfires. And then by January 2025, agriculture and climate. So across all of these different themes, our proposed module structure consists of 5 different lessons. Now, this isn't something that's written in stone, and we're already starting to make some variations on how we do this. But for each data stream that we ingest, we're going to look across the whole data science lifecycle, including generation and collection of data, you know, how to process it and store it, where we'll look at both local and cloud-based options for processing and storage. For management and analysis, we'll be thinking about both statistical analyses, but also the management in terms of creating good metadata, or being able to interpret metadata from existing sources. Visualization and interpretation will include maps and charts. Many of us are GIS experts, so we tend to have a little bit of a leaning towards producing maps, but we also really love charts, so there's going to be a lot of both. And then finally, we'll talk about open science and community engagement, you know, basically how to empower someone who's learning in one of our modules to share what they've done openly and, you know, with people who may not have even heard of open science before. So what is our philosophy? You know, our pedagogical philosophy is an emphasis on active learning. So active learning, if you've not heard the term before, it's the process of encouraging students to focus not only on what they're doing, but also to think critically about it. And it engages people through activities such as reading, discussing, executing code, and writing, in addition to listening. In an asynchronous environment, we're really at the cutting edge of figuring out how to employ active learning strategies effectively in that type of environment. So the idea, though, is to move beyond just reading or listening to pre-recorded things and to move towards some type of active engagement where people need to think about something from their past to retrieve past knowledge, or look at an image, or interact with the real world. So this is probably a good time to practice what we preach and pause. I just want to ask, you know, has anyone had any past experience, whether in the classroom or asynchronously, with active learning?
This is Anise Williams again.
Thank you.
I'm actually, well, they asked me to come back. So in 2024 will be our 2nd year doing it. We came up with a online, like co-working community call session. It's called Pathways to Open Science. And it was really actually geared more towards marine and environmental science. But we, as a co-organizer, we determined which speakers or what kind of speakers we wanted. So we had Dawn from Esri. She was one of our speakers. She came and spoke, and just different colleagues or people that we knew that would have good insight on marine environmental sciences, like what is our path to open science. And as a co-organizer, I just gave like a brief presentation on my experience, you know, like my background. I was able to travel to different countries to do research, just being able to give that opportunity or knowledge to people that may not knew existed, and then just learning from the different speakers about what they went through or what avenues they had to take to do research or get data. And then also it was a good tool for networking as well. That's just like a brief summary.
Thank you. Sorry, my mute button wasn't behaving, but that sounds like a really great experience. Is there anyone else who would like to share some of their experience? Robin?
Yeah, I can go ahead. As a software developer, I feel like we do active learning all the time through pair programming or working on stepping through some sort of training together as a group and then discussing. And at NSIDC, we previously have had hack weeks where we can get together with other people and learn about something as a group. So very, very active.
Awesome. That's great. Does anyone else want to offer a reaction? Okay. Well, all right, go ahead, Jinyi.
Yes, I have the same feeling experience as Robin, and it's because I need to work for developing web mapping software. So I think at that time I have very strong aim and goal to achieve, to learn, and then I do the work. So I think at that time it's the most active goal for me to learn the specific knowledge.
Thank you. Yeah, one thing that I think that we'll need to get creative with is in an asynchronous environment, how do we still encourage activity? So some of the things that we've been brainstorming about is creating some kind of community mechanism within our module where people could post to a message board or do something like that. But it's very much, we're at a phase where your guys' input can influence how this develops. But one of the things that we hold as a high priority is to take, we believe that active learning is very important for people to solidify knowledge in their minds. So we're really looking for ways to do that in the online asynchronous environment. So, we also believe that evaluation is important. In order to foster an inclusive environment with active learning, it's important that folks understand the expectations and that those are clearly communicated, and that the assessments are timely, and that we also demonstrate examples of the ideal results. So, what we've had in mind for these modules is basically walking through a workflow with some data set and then extending it out so that the learner can repeat it, maybe in a different geography or maybe with a different variable. And then, we're thinking about how to incorporate some quiz type functions into our R code and our Python code in order to give assessments in near real time. So clearly defining the learning objectives also is an important part of this. And this idea of feedback early and often, that's something we really take to heart. And, that's part of the process that we're undertaking today. We're still early in the process, but, we're looking for feedback now, and then we'll continually be looking for feedback as things progress. Sorry. So that's very much in line with the software development paradigm called Agile. It's not just a software development. I think actually Agile, it came out of, Toyota, I think, if I remember correctly, in the development of new vehicles. But in an Agile project, you don't wait until the product is finished to release it to users and get feedback. That was the approach where you kind of develop something and then you let it out into the world. That's a waterfall approach. In Agile, you let things out into the world as you're developing them. So this project takes an agile approach, and I have a number of different roles listed here that help us to achieve this. The most important one to emphasize today is this OST, or Open Science Team, where we're going to hope people get early access to our modules and to give us feedback before we're finished developing them, so that we can improve them again early and often. Sorry. So I guess another team I would highlight here is our consultation team, which consists of some subject matter experts and senior staff. So for the water resources module, we did have a kickoff at the iGuide forum, which my slides are a little bit out of order. I apologize for that. But we had a kickoff in October of 2023. Here's an image here on the right, where we had a group of people in the room and a group of people online, and we interacted with this NSF project. It's called the Institute for Geospatial Understanding through Integrative Discovery Environment, or iGuide. And what it has many similar principles to TOPST. And so, I think it was a really good example of open science for us, for a NASA workshop within an NSF workshop, where we met a lot of great people and got a lot of very early feedback. What we had proposed for our first module, there's two specific data sets that we're looking at. One of them is a historic database on water security, which is called the WSIM GLDOS database. What it identifies, there are several different variables in this data set, like temperature, precipitation, soil moisture, evapotranspiration, runoff, water surplus. But ultimately, one of the main uses of it is to identify anomalies, either in terms of drought or in terms of flooding. And again, it has this long historical timeline from 1948 to 2014. And there'll be a new version coming out that extends past 2014. And then, a second thing we're looking at versus the historic data is the near real-time product from MODIS on flooding. So the MODIS near real-time, it has 1, 2, and 3 day versions. It is something that is updated on a daily basis. And, our idea is kind of to integrate what's happening in real time with the background information of what has happened historically in different areas. I say that, I don't have a slide on this, but we're also looking at, population and geographic boundaries as other inputs to help us analyze each of these data sources. So I mentioned the subject matter experts. I just wanted to thank them again here. Tom Paris, he's an expert in impact and vulnerability assessment. He spoke with us at iGuide. All of those materials from iGuide we've put online through Zenodo, and I think they've already been made available to you, but we'll make them available again if you want to go back and watch the presentations from our subject matter experts. Laura Lynn Jessette from the Columbia Water Center talked to us about local water data and water quality. She's influenced us to look at a case study on lead in water. So ultimately in our module, we'll have something similar to in the textbooks, at least for me when I was growing up. Oftentimes in a textbook, there'd be a subsection where it's a case study or a learn more. So what we're hoping to do is have a small offshoot case study about water quality, where we incorporate some of the suggestions that our subject matter experts gave to us. Ryan Mead from the State University of New York at Binghamton. He's part of the Educational Opportunity Program, and he's advised us on pedagogical approaches, and especially on approaches to inclusive learning. and Nancy Degnan, who is the assistant, or served as the assistant dean at Columbia University School of International and Public Affairs, and is currently an executive director of the Center for Environmental Research and Conservation. She also has significant background in pedagogy, so she advised us also on things like self-assessment of teams and personal relationships to water, and how to incorporate people's personal perspectives in creating curriculum. Deborah Balk has expertise as a demographer. She advised us on human impacts from things like flooding. She's done a lot of research on things like low elevation coastal zones and exposure to floods in urban areas. So she helped us to think about how are we going to integrate the human impacts part of the puzzle with this earth science subject. So as I said, the artifacts from this meeting are available on Zenodo. Includes a transcript. It includes a video. The video is also up on YouTube. It is quite a long thing, but it can give you some of the history of how we got to where we are now. So I'll be sure to share these slides out and these links after the presentation. So, after this kickoff at the IDGuide workshop, we've put pen to paper, the rubber has met the road, and we've started our development in earnest. That includes a GitHub instance, which the link is here at the bottom, and thank you, Camilla and Juan, for putting these links in the chat. But Juan, did you want to say a word or two about the GitHub?
Yeah, sure. So the GitHub is work in progress, still under construction. But in the meantime, I just wanted to mention OpenScapes because they're an organization that helped us build the GitHub IO. And hopefully along the way, we'll be able to add more information to this GitHub and use it kind of like as a central place to get information about this project, as well as to be able to see the modules and interact with them as well.
Thank you, Juan. So this is open for people's review, but as Juan said, it's very much a work in progress. But ultimately, when the module is finished, it's going to live in a GitHub instance. Maybe with this URL or maybe with a NASA specific URL. Some of those details we're still working out. So I mentioned this agile approach that we've taken. So we put that into practice using a project management software called Asana. What Asana allows us to do is to, in the agile framework, there's these things called PIs, or project iterations, which generally last for a couple of months, and then they're subdivided into these other things called sprints. If you have experience with coding, you've probably seen these terms before. So the sprints are focused on very, very specific outcomes over short durations, usually lasting 2 or 3 weeks. So our team has been putting a lot of time into defining specific tasks. You see some of them listed here. Like for instance, our modules will be bilingual, so we'll have a task to translate them from English to Spanish. There'll be some events that we're taking part in, as the American Association of Geographers meeting in April, for instance. And we've been working on preparing both text outlines of workflow narratives and also doing some of the coding to actually create them. In the agile framework, there's this idea of a Kanban, which it's basically a progress board. So we can keep track about which tasks are happening and at which point in the process are they. If they get blocked for some reason, then everyone is able to see that. So, you know, in an engineering workflow, these things lead to greater efficiencies. What we're doing in this project is quite exploratory in that we're applying these engineering philosophies to curriculum development. I don't know if there's been very many instances of people merging these worlds before. So we're learning a lot, and I'm sure over time we'll get better at it, and hopefully, you know, at the end of the day, we'll be able to create some best practices that will make it easier for other teams to do this type of thing. You know, in terms of the narrative, our research assistants have been working on annotated bibliographies and compiling those bibliographies down into write-ups. This too is a work in progress. These are just some examples of the type of work that has been produced so far. So they've been reading a lot of papers and summarizing them and kind of keep boiling it down and boiling it down. Here's an example of some of the pseudocode that we've created for the data analysis tasks. So although we'll be using both Python and R throughout the project, we made the decision for the water resources module to use R as the primary language for development. You know, we'd welcome feedback on that, of course, but you know, our general approach is to start by marking up a document with pseudocode, and then we're in the process now of going back into these documents and actually writing the code. We're doing that as, you know, team coding approaches where there's a lead developer and some partners who are helping to put it together. But again, we're still very early in this process. So the Open Science Team Kickoff is, you know, you are here. That's what's going on now. What are we hoping to get out of this? Well, as you see here, you know, some of the initial thoughts that we have are that the Open Science team can help us review and test and review and give us feedback to help us improve both the narratives that we're coming up with, or also our approaches to coding. It's all on the table. We want to know, is this a user-friendly thing? I have to say that it's not our objective to teach people how to code. It's more our objective to use code to demonstrate how to access and analyze NASA and other sources of data. We anticipate that there'll be 5 hours of total commitment for people who agree to be on the Open Science team. The kickoff being, you know, the first hour today. And then by early January, we hope to have some early deliverables that we can distribute to the team and get some feedback on. And then by mid-February, we'll be hoping for a beta review with the goal of releasing the module by the end of February. So it is this very accelerated timeline. You know, as I'm talking it through, I feel a little nervous about the timeline. But again, I do trust in the process, and that's part of the reason why we're imposing Agile on this, so that we can trust the process and hope that it will bring us to where we need to be by when we need to be there. You know, that being said, we'll see what happens. You know, this is our first module, and like I said, we'll learn a lot. We'll get better at it, but right now we're in the phase, you know, the sometimes difficult and painful phase of learning something. So what would you get in return for being part of the Open Science team? You know, what we can offer is acknowledgement. Anyone who participates and contributes to the project will be listed on our GitHub and website as contributors. You know, we also want to make sure that, you know, if this is something that you could utilize on your resume, that we'll, you know, distribute certificates of contribution to each one of our participants so that you have this proof that you took part in this NASA initiative. And, you know, we really hope that that will help people to get grants and get jobs and things like that. Finally, we do have the possibility for 10 OST participants to apply for, you know, a very small stipend of $100. But with this idea that it's a 5-hour commitment, we thought at a very minimum, if we could provide people with $20 an hour for their time, that would be good. You know, this would be delivered in the form of an ATM card, which could be used for anything, including just going to the ATM and withdrawing the $100. So I know that this is, you know, it might not be important for all of our participants, but for some of our participants, especially those who are current students, you know, it's extremely important, I think, and we want everyone to get acknowledgement and credit for the work that they're doing here. You know, all of you have been kind enough to volunteer to sit in today, and we appreciate that. But we're about fairness and equity, and we want to make sure that you do get the proper acknowledgements if you do participate. Sorry. Sorry, my mouse is not working. So then I guess I wanted to open the floor at this point for, you know, any initial questions or feedback. So I've given a high level overview, and we haven't delivered the details yet. But today was really just to orient everyone to what we're trying to do. And then, you know, if you think that you still want to be part of the open science team and make contributions, which I hope everyone does, then, you know, by January, we'll have some materials for you guys to review for us. In the meantime, there's the materials from iGuide that provide like a some more background information on what we've heard from subject matter experts. But I feel like I've covered quite a bit, so I just want to pause and see if anyone has any questions or comments. I guess maybe it was crystal clear. Hazem.
Thank you so much for the great presentation. I have a question in the early slides. One of the slides was showing the timeline and the different modules. You talked about the water. Is it going to be the same team looking into the other modules like wildfires, like air quality and so on? Or is it going to be other
Yeah, so in terms of the development team, it's going to be pretty much the same development team. So, you know, all of the people who are funded on our staff will be pretty much the same group. In terms of the open science team, we're open to different possibilities. You know, I did mention that there are 10 stipends there. We actually have 10 stipends for each one of the modules. So I imagine that over time, the open science team will grow. But if there's anyone who's interested in multiple modules, you know, interested in one but not another, we certainly will make it possible to participate in them.
Okay, thank you.
Thanks. Albert?
Yes, just a quick question. I would like to ask if there is you have any link with the data carpentries. What is the link between this project and the software carpentries, if there is any?
Yeah, absolutely. Juan, maybe is that something? I know that you took part in the carpentries training. Maybe you could speak to carpentries.
Yeah, so some of hopefully we will have a couple of more people take the carpentries, what is it called, like a training. It's a 2-day training. So one of the things that we're trying with this project is to incorporate some of the learnings from those trainings. For example, carpentries, mentions a lot about creating a code of conduct and making that explicit, or having feedback from participants and adjusting your lesson or your presentation according to that feedback. Aside from that, we're not necessarily directly engaged with carpentries. We do engage with the community through OpenScapes, through their Slack, or also with their working meetings with OpenScapes. So that's kind of how we heard about carpentries. I don't know if I have anything else to add on.
Yeah, thank you, Juan. So in short, yes. We're also working, many of us are at Columbia University, and we have a Center for Teaching and Learning, which is, a bunch of people who think every day about pedagogy. So we're interacting both with the carpentries group, but also with the group at our university. And then some of the subject matter experts we've brought in have been from other institutions, but they've also worked in curriculum development and pedagogical spaces. So yes, carpentries, but then also additional folks too. Thank you for the question. Somehow, my Google Slides mouse, I skipped this slide, but I just want to say, in terms of the technical frameworks, I mentioned for the water resources module, we're looking at R, and then within R, we're looking at Quarto as the system for putting it online. We're using repositories in GitHub, but also YouTube, Zenodo, the different NASA data centers like CDAC. Ultimately, we are going to support online interactive code. So we're still in the process of figuring out exactly where that will be, and likely it will be in multiple ecosystems. But things like Jupyter Hub or Google Colab, those are some of the things that we've looked at up till now. So are there any other questions or comments at this point? Go ahead, Juan.
Yeah, Kate, I just wanted to add to the previous question. I forgot to mention another organization that we're interacting with, Metadociencia. They also won an award through TOPST. So we're trying to work with them to see how we can start including more people from different continents, or perhaps develop a module, not in English, but start the module in a different language and then translate it to English. So those are two organizations, including OpenScapes, that we're interacting a lot with, and sharing some of the knowledge that they have with us, and vice versa.
Thank you, Juan. Any other comments or questions at this point? Okay, if not, I have some slides here on where we're headed. In module 2, which will kick off in January, we'll be looking at environmental justice. Some of the initial data sets, which these are subject to revision, but some of the initial data sets we've identified to incorporate is the EPA's EGA screen tool. There are several data sets underlying that. The Global Gridded Relative Deprivation Index, or the GRDI, which is a data set that Juan has worked very intimately in developing, that identifies multidimensional indicators of deprivation and poverty, and is available at the 1 kilometer scale globally from CDAC. Within the US also, there's social vulnerability grids, This is actually being updated to include the year 2020 as well. So these are some of the things we have in mind to get started with. We'll also be looking at health and air quality starting in January, which Hazim, I think maybe you could help us a lot to refine this. But some of the things that we had in mind was the near real-time air quality from Lance. And there's some PM 2.5 data sets that are distributed by CDAC. I'm sure that ASDC has even more sources that we might want to incorporate. So I'd love to talk to you sometime about that.
Absolutely, yes.
Thank you.
I actually have a question. I'm sorry if I'm interrupting. It's related to the other groups. I'm pretty sure that there is no duplication of effort. But is there anybody else working on air quality from the other school principal investigators?
I'm not 100% certain. Juan, do you remember if Metadocencia had mentioned that? I can't remember what they said they were focused on.
Not particularly. I can't recall now, but from carpentries or Metadocencia is more like a general learning that they're providing.
Yeah, in the chat, Juan had put a Slack channel for this project. If you throw that question up in the Slack, then what we can do is we can reach out to the other funded participants and try to, figure out. I'm sure someone's working on it. I'm just not sure who.
Okay, thank you so much.
Thanks. So then after health and air quality, we'll look at disasters and wildfires. So we're thinking of, there's some extreme heat data sets from MERA2. There's urban heat island data sets from CDAC, burn area from VEERS and MODIS. In terms of climate and agriculture, which will be our final two modules, we'll be looking at precipitation data, trim data, some seasonal climate forecasts. One of our co-research centers at Columbia is the International Research Institute for Climate and Society, or the IRI. They maintain a climate data library that is extremely robust. We'll be looking at groundwater and soil moisture as well, including other variables on crops, cropland, evapotranspiration, and land cover. Now, across all these, we'll be including population and infrastructure data. So I mentioned this briefly earlier, but CDAC in particular has data sets on gridded population and some existing APIs for interacting with, querying population data sets. Also, the nighttime lights data from JPL. We work closely with it at Season to create settlement extents. So nighttime lights from VEERS will make it back in here from the Black Marble. There's also data sets on infant mortality and other demographic information that we'll seek to include. So with that, I think, Camilla, could you take the link for the Google form for feedback on today and throw it into the chat? I thought I had added a slide for it, but the way that my mouse has been jumping around, I'm not sure anymore. Let's see if I can find it.
Sure. I'm just testing this before I send it. 1 second.
No worries. In the meantime, please, let's open the floor if anyone has comments or questions.
I have a question. Do you plan on using R for all of the projects, or do you think you'll go between Python and R? What's the thoughts there?
I think we'll be using a lot of Python. People on our team, many of us are Python developers, but many of us are also R developers. And it turned out that for the water resources module, it was kind of a practical decision to use R because there were some packages that we wanted to leverage against the WSIM data set that R had, really good packages for that. But we're definitely going to be using Python as well.
Yeah, do you plan on using like Jupyter notebooks for engaging?
Yes, absolutely.
Okay, awesome. Thank
Which
you.
in R, I'm more of a Python programmer myself, but Quarto is kind of the R equivalent of a Jupyter notebook.
Yeah, it's my understanding that you can also use Quarto for Python now too, so could be
Cool.
used for everything. Yeah.
Awesome. Thank you for that feedback.
Yeah, I just wanted to add that I think for now we'll probably have the modules, whether they're in R or in Python, on GitHub, so they'll just be easily accessible. But hopefully we'll also have them as notebooks, live notebooks that people can interact with just online.
Yeah. There's a question in the chat: R-base or tidyverse? Do you know the answer to that one?
No, I don't. But
to be determined, I guess.
I have used
but
tidyverse, and I think it's fast, but I'm not. Either way.
Yeah. No,
maybe Greg
one of our,
can chime in.
Yeah, I think Greg had to drop, but one of our other colleagues, who's a very like a Power R developer. I don't know, Hashim, do you have any like preference between R-base or tidyverse?
Tidyverse gonna be much more easier and useful for and easy to understand.
Cool. Yeah, so as you see here, the whole point of this and like the whole open science philosophy is to just have these discussions with everyone in the room. And there are a lot of moving pieces, and there are a lot of things that we haven't come to final decisions on. So we're really open to having you guys influence us on those things. So I do just want to mention that Camilla, she put a Google form in the chat. It's very short. It's three questions. But if there's anything that you didn't get to say today that, I asked that everyone who participated today, please just fill out the form. It will help us to one, keep track of everything and make sure that it's on paper. Although this is recorded, and then maybe you'll think of something a little bit later that you didn't get to say that you'd rather put in the form. So we'll email that link around also. Okay. So but before we close for today, are there any final thoughts, questions, comments? Okay, if not, I just want to thank you again so much for taking the time to be with us. We will follow up to, make sure that this is something you still want to be a part of, and I hope that you do. We'll also be asking about, whether you would like to be considered for one of the stipends that I mentioned, and those are open to all participants. So if you want to be considered, we'll reach out about that. Other than that, thanks again. I hope that you found today informative, and I look forward to continuing to collaborate.
Thank you.
Thank you, Keith.
Bye, everyone. Thank you.
Thank you. Ciao.
Thank you very much.
Thank you. Have a good day, everyone.
Thank you.
Thank you.